Okay, so are you ready to decode some serious data?
Always.
This time we're tackling seasonal decomposition, and no, it's not about your garage or
Yeah.
anything like that.
Though that is a seasonal mystery worth exploring.
Hmm. Maybe another time. But seriously, you all sent in this really cool article from Geeks for Geeks about a method called STL.
Yes,
Yeah,
yeah.
yeah, STL. And it's all about helping us unlock some really fascinating data detective skills.
That's a really cool method. STL, or, and forgive me because this is a mouthful, seasonal trend decomposition using LOESS.
You're right, that is a mouthful.
It is. But it's really about finding the signal in the noise. Imagine you're trying to understand long-term trends, but you got all these predictable spikes and dips messing with your data.
Right, like trying to figure out if your website traffic is actually growing or if it's just the holidays or something like that. So, how does STL actually bring order to all of this chaos?
It acts like a statistical filter. It separates those repeating seasonal patterns from the underlying trend.
Okay.
Think of it this way. If you're charting your website traffic, STL helps you see the difference between that overall growth of your audience versus maybe a temporary boost you get from, like, I don't know, a Black Friday sale or something.
Okay, so rather than just seeing this like jumbled mess of data, STL helps us identify those individual components that are really driving those ups and downs.
Yeah,
And to do that, it breaks down time series data. So that's just data collected over time, right?
exactly.
It breaks that down into three key parts.
You got it. We've got the trend. So that's the long-term movement in the data,
Yeah.
like the slow and steady growth of your website over time.
Got it.
And then there's the seasonal component. Those are those recurring patterns that we keep mentioning, like the holiday spikes in traffic.
So it's like seeing the forest and the trees, the big picture, and then those smaller cyclical changes. What about the third part?
Ah, that would be the residual.
For residual.
Yeah, think of it as the random noise in the system. It's everything that's not explained by the trend or the seasonal pattern.
Okay.
Like if, I don't know, like a sudden surge in traffic because your site got mentioned on a popular podcast or something.
Okay, so the residual is basically where all the surprises hang out. Kind of fun, actually. It's like you never know you're going to get part of data. But seriously, why go through all this trouble to break down our data like this? What's the big payoff?
So several things, actually. First, pattern identification.
Okay.
So by isolating those seasonal effects, we get a much clearer picture of what that underlying trend actually is.
Right.
And that's really crucial if you want to actually make accurate predictions.
Predictions. So that leads us to...
That's the second big win.
Okay.
Speaking of predictions, that's
Yeah.
the second big win. Being able to look at that and then model it really helps you to be able to predict things more accurately. But here's where it gets really interesting. STL also helps us spot those truly unusual events.
Anomalies. I love a good mystery. Tell me more.
Think of it like this. Once you've accounted for that expected trend and those seasonal ups and downs, anything that falls outside of that pattern really sticks out.
It's like that one time my website traffic tanked for seemingly no reason, and it turned out a major news story had completely overshadowed everything online that day.
Oh, wow.
If I had been using STL at the time, I might have been less panicked and more like, okay, this is weird, but let's see if it fits into any patterns first.
Exactly. It helps you put those unusual events in context instead of reacting to every blip in the data. You can really focus on the changes that really matter. And that brings us to the final benefit. Better statistical analysis overall.
So it's not just about understanding the past, it's about making smarter decisions in the future.
Exactly.
I like it. But before we jump ahead, the article mentioned these two key parameters, seasonal and robust, that we can tweak when we're actually using STL. What's the deal with those?
So they're like fine-tuning knobs for your analysis. The seasonal parameter tells STL how long a typical seasonal cycle is for your data.
So if my website traffic tends to go crazy every December, that seasonal parameter would be set to 12 for 12 months?
You got it.
Okay.
You're telling STL, hey, look for patterns that repeat every 12 months.
Got it.
And then there's the robust parameter.
Okay.
That one's all about handling those unexpected data points.
Okay.
Like if for some reason your site crashed one day and it threw your traffic numbers completely out of whack.
Okay, so robust is like that friend who doesn't freak out when things get a little messy.
Exactly.
Speaking of things that are messy, the article dove into some of the how-tos of actually using STL.
Okay.
It mentioned Python, which it seems like is the go-to language for this kind of data crunching these days.
It really is. Python has become, kind of the darling of the data science world.
Yeah.
And it's not hard to see why, right? It's relatively easy to learn.
Okay.
Even if you've never, touched a line of code before.
Right.
and have these amazing libraries that do a lot of the heavy lifting for you.
Libraries. Is this like a secret data scientist clubhouse or something?
Kind of. Imagine a library,
Okay.
but instead of being stocked with books, it's stocked with pre-written code modules.
Okay.
So instead of having to reinvent the wheel every time you want to do something complicated, like let's say perform a seasonal decomposition,
Right.
you can just like borrow the code from a library.
Okay, that makes a lot of sense. So less time coding, more time actually analyzing and understanding the data.
Exactly.
Are there any particular libraries that are popular for using STL?
Absolutely. The article specifically mentions stats models,
Okay.
which is like a one-stop shop for time series analysis in Python.
Convenient. So I fire up Python, I import stats models. What happens next? Is it just a matter of feeding the FTL function my data and hitting go?
It's surprisingly straightforward.
Really?
You tell the function which data to analyze,
Okay.
and then you set those key parameters we talked about, seasonal and robust.
Right. And those parameters are where we fine-tune the analysis based on the data we have and what we're trying to achieve.
Yeah,
But once those are set, STL just does its magic.
exactly. It churns through your data. It spits out those separated components, your trend, your seasonality, and your residuals.
Hi.
And then you can really start digging into the insights.
So if I wanted to just see the long-term growth trend of my website traffic without those holiday spikes and random dips and all that, STL lets me do that.
Precisely.
Wow.
You can isolate any of the components.
Okay.
You can visualize them. You can perform further analysis.
Wow.
It's like having a set of statistical X-ray goggles.
Okay, now I'm really starting to see the power of this.
Yeah.
We've talked about how STL helps us understand the past,
Right.
but what about predicting the future?
Yeah.
The article touched on this briefly. It mentioned something about forecasting models.
It's a natural next step.
Okay.
Remember how STL breaks down our time series data into those separate components?
Right.
We can actually use that to make more accurate predictions.
So it's not just about seeing the patterns, it's about using them to anticipate what might happen next. Okay, tell me more about how this forecasting magic works.
Well, let's say you want to predict your website traffic for next year, right?
Okay.
Using STL, you've already got your historical data neatly separated
Right.
into its trend, seasonal, and residual components.
Right. Like ingredients all prepped and ready to go.
Exactly. Now, this is where forecasting models come in.
So we've got our data broken down into these bite-sized pieces by STL. How do we actually use those pieces to predict the future?
Think of forecasting models like specialized tools, right? For each part of the recipe. You might use one model to project the long-term growth of your website traffic by looking at how it's steadily increased over the past few years.
Makes sense. You'd want a tool that's good at spotting those overall trends for that.
Exactly. And then you might use a different type of model to predict those seasonal swings by factoring in how holidays or seasons or even specific days of the week tend to impact your traffic.
So instead of trying to predict everything with one giant, complicated model, we can be more strategic and use the right tool for the job.
Precisely. And once you've got predictions for your trend, your seasonality, and remember that residual component, all those random ups and downs, you can even model that to some extent.
Wow. So we're not just accounting for the expected, we're also factoring in a bit of unpredictability.
You got it. And then you combine all those predictions back together, and you get a much more accurate and nuanced forecast than you would have gotten otherwise.
This is blowing my mind. Okay, so we've covered the what, the why, and even a little bit of the how of STL, and I'm really starting to see how powerful this technique could be for anyone working with data that changes over time. But before we wrap things up, the article ended on such an interesting note, and it's something I've been turning over and over in my head ever since I read it.
Oh, you mean the idea of using STL to analyze data from our own lives?
Exactly. I mean, we've been talking about website traffic this whole time, but what about things like tracking our sleep patterns, our moods, our productivity even?